So this is the table of content. We're gonna have a brief introduction about the failover scenario. We're gonna have like the first steps of reading metrics, trying to make a better diagnosis. We are gonna be like, let's checking the isolation and stabilize our services, documentation, and we're gonna have a brief summary. So the session's goal are defining at the end of the session where you will be able to define an execution plan when a service is degraded or start failing. When we start like seeing this kind of behaviors in our infrastructure, we can define an execution plan. We should identify possible applications, isolate them, and get back to a stable state. I'm gonna be sharing you like my tips and tricks about how can we do this part of the isolation. We're gonna be like defining a document to write down your efforts of your team when incidents happen and make plan for the future over once the emergencies are resolved, and we can set a clear path for the next steps in the future. As briefly introduction, let me, oh, sorry, I skipped one. As briefly introduction, let me summarize what we're trying to understand. We're in charge of a set of services that are consumed through a mobile or web application. And those services can be RESTful APIs or can be whatever you think, but the idea is that we have these services deployed in a virtual machine. And this virtual machine basically is based on Linux. So these VMs are behind maybe a load balancer or covered by an Autoscaling group. And part of the infrastructure will look like this. We have our web and client applications that are consumed via load balancer. And maybe I'm not sharing like the exposure of this load balancer to the public network, but let's assume that it's happening. And we have this EC2 instance, and this is for AWS, but it can be replicated to many cloud providers, let's say GCP or Azure. So these instances are being covered by our Autoscaling group, and we have defined a threshold that is maybe a basic threshold, nothing fancy, that increments via CPU or memory, whatever. Let's say that we start with this infrastructure for the beginning, right? And this application is consuming, reading and writing from a database. So that's like our basic scenario. We have this infrastructure whatsoever at the beginning of this part of our scenario. And let's say that we release a new version of our application, and this version has been deployed in the morning. And you know, applications and versions smells when you have the most fear, you need to go out on Friday, or you know, something like that. The releases knows when you have more hurry. And the part of this is that we have integrated in the pipeline different tests and to ensure quality from the quality assurance team. And maybe we didn't cover at all. And at the simple view, this test needs to cover some parts, but we are not sure about that. And apparently no warnings or error have been triggered in a couple of minutes. So we are good to go. We're packing our stuff. And then suddenly, after a couple of hours, an alarm has been triggered with some requests returning status 500. But most of these requests seems to be taking longer than normal. The issue is that we start seeing a degradation of the system because the API or the RESTful API was responding in the order of 100 milliseconds, and now is 1,200 milliseconds. So it's over more than a second, and we start like getting like not really confident about this release. But this is fine. Maybe we can find solutions. And the ideal is, what should we do now? From this part of we start seeing this degradation, maybe we start seeing that our application takes longer. Some services are start like getting, you know, the spin off of the icons, and we can struggle about, we can live there. We can leave the system doing that kind of stuff. So let me share with you the first steps that I will do if I'm in that particular scenario situation. And the first point is reading metrics. Sometimes metrics can help us a lot. It can be boring, but can help us a lot about what we are trying to achieve. The first thing we should do is check in the server if it's an actual load issue with a command. I also, like the first command I try to type is uptime. It's really easy. The uptime command tells us how many days and when the server started, how many users are logging, but we're looking for the load average. And this load average are gonna give us 3 different numbers, 5.24, 3.6, and 2.82. But what those numbers, what does it mean, right? Those numbers represent the average of the load system over a period of 1, 5, and 15 minutes respectively. So we can say that we have a load average of 5.2 a minute ago, then 3.6 minutes ago, and 2.8 15 minutes ago. The load average represents the average number of processes that have to wait for a CPU time. And let's assume this, that an idle system in theory should have a load average of 0. I created like this representation of how we look the load average if we have like this stored with cashiers. And let's say that we start with an average load of 0, and then suddenly came a process that wants to buy something or process some data. And now we have an average load of 1. So then in a couple of 5 minutes, 4 processes came to the CPU or the processor and tried to use the CPU. So now the system tells us that we have a load average of 4. But when we start seeing that, it's like all these processes are waiting time to be processed by the processor. So we can say that we have kind of a load, a high load right now, because for one cashier, it's gonna take maybe 20 minutes, maybe more or less, to process all these requests from different processes. So what should we do? Maybe the first thought in this kind of scenarios will be like, well, let's do a vertical increase of our resources, right? So maybe we can add another processor to our server, and we're gonna have a dual processor, and maybe the 4 processes that were in line were distributed between the 2 cashiers. A question to the public, and it's free to say, anyone can answer. What could be the average load right now for this particular system with 4 processes and 2 processors? Anyone? You can write in the chat if you're kind of shy. Don't worry.
Or you can unmute yourself and share with
everybody.
Distributed.
For me, it's 4.
4? Who gives more? Who gives less?
Or who agrees?
2. Okay, Kristen, thanks. 2. Great. Let me. Okay, 2 again. It's winning the 2, Rachel. What do you think? What's gonna be the load average for this?
I'm
scenario?
not sure. Do the big
Okay.
reveal, Edwin.
Yeah, I can reveal the result. It's gonna be 4. Because remember, the load average is the number of processes we're trying to process at the same time. It doesn't matter how many cores we have. And that can be tricky, because if we start seeing like the load average is going to 10, 20, and you start like getting worried that maybe 100, you start getting worried about, well, we have a lot of processes waiting for be processed. Yeah, but you have a 12 core processor. So maybe this load is distributed between all our processors. So it's relative. How high is a load high depends on the number of processors also. For this particular scenario, a load of 4 is not the same to be processed by 1 cashier rather than 2 cashiers. So we need to take considerations about the load average and the number of processors we have in our servers. So let's say that we have now 8 processes waiting to be processed. this could be really a worst scenario being just held by one processor. So can you see like the immense help that we have with two processors? And now, if we write uptime in our server, we're gonna be like the load average of 8, 4, and 1. Like 1 minute ago, we have like eight processes trying to be processed, or average load of 8. Then 5 minutes ago, we see like we have 4 in line, and then 15 minutes ago, we see 1. So we can take a little diagnose of that 15 minutes ago or 5 minutes ago, the things start getting worse. Maybe we spawn a lot of processes, maybe a new processor start like taking more CPU that we were expecting. Maybe our application to start processing images or processing a report, I don't know, but this gives you like the idea when start happening the high load of the average load. Then suddenly and automatically we start seeing like all the processors start like going down, and we see like the average load of 5, then an average load of 3, and then suddenly the server is going to a normal or an idle state with 1. So the representation, if we run again the uptime comment, you will see that we'd have 1 minute ago, sorry, a 3, 5 minutes ago a 5, and 15 minutes ago an 8. So we can ensure if we run like this command and say, okay, 15 minutes ago we were in a high load, but right now it's getting better. It's nothing to worry about. We can say that the system is recovering from an high load state. So you're gonna tell me, Edwin, so is high load a bad thing? What's a good threshold to avoid high load? And that depends. The threshold will be a combination of different factors. The first one will be the resources in our server, memory, CPU, the IO quota for writing and reading. But it's gonna be it's gonna depends on how our application is defined, the logic behind it. So setting a threshold, like sometimes when engineers told me, well, I'm gonna set a threshold of 70% for the CPU. And my first question is why? Why 70%? Is there a particular number you have in mind for that? And all the answers is, well, it's a standard threshold. It's something from good practices. I would say the good practice is go deep and understand really well your application and define your threshold based on that. And we're gonna see that in a couple of slides. Is high load a bad thing? Not really. Sometimes we need a server working really it's like a machine that, well, in fact, the server is a machine, but we see like some things need to be cached in order like to respond faster. Let's say that you're opening a file, and at the first time when you're opening the program and the file is getting like start really the server start like really getting like a little bit slow, but then suddenly everything is cached, everything is up and running, and maybe a high load is not a bad thing. It's something that the servers require, like to be processing everything faster or working everything faster. And again, different factors can trigger high load, each of which affect permanently performance differently. And we're gonna see like something like which are the things that can go wrong in high load. When we're troubleshooting based on average load, the important thing is to understand why is the load high. So normally there are following 3 categories. Is the CPU load that we were like checking with the average load in the uptime command. Maybe it's a memory load issue, or maybe it's an IO load that constantly go with waiting for reading files from a disk or some peripherals. And this is my second favorite command. The top command is basically you can find top everywhere. And the idea of top is that once you run top, you can search for different factors. This is the first one, is for the CPU, and it's divided in different categories. more than 30% is used by the user. US is for user. 1.4 is for the system. This part is for idle state, but sorry, this part is for idle state. So we can see like 1/3 of the, almost 1/3 of our, no, 1/4 of our system is used by the user, but most of them is in an idle state. And this part of the 1.4 is way well, WA, that is waiting for an IO execution, mostly of the disk. So summary is user, system, idle state, and waiting for an IO interruption for writing to the disk. So as we can see, this system is healthy because we have more or less 64% of the state idle. The idle state is not waiting, is waiting for some processes to be processed. And also we have like this column that we can see how many CPU percentage is taking those processes. Let's say that from all the processes we have, 58% is from MySQL, 55 is from Web1.
Mira, la idea que traigo es más o menos ahí.
Don't worry, you can share the idea with everyone. And then we have like for wdata, sorry, this is not the users and these are the comments for MySQL and PHP. So we can say that we don't have like a high load with the CPU. Yeah, thanks a lot. We can say that we have a lot of processes taking over the processor, but it's not a big deal at all. We are seeing like the idle state is fine, and we have like 32% of our processors being invoked by the user. If we go to the memory load, and uptime can give you good hints about the memory load. And this is kind of tricky. Let me explain why. Sometimes, and you can see like this number is decreasing over time, from time to time. And you just start like seeing like the total amount of memory and the usage amount of memory, this number is starting like getting lower and lower and lower. And then you see like the free, sorry, this is gonna be increasing. Sorry, the use is gonna be increasing, but the free space is gonna be getting lower and lower and lower. And one thing that you should be aware, guys, is that Linux systems in particular, once you open a file, the system refuses to close it. And these files is stored in memory. Most of the time, these files are not, and it's really serious. You open a file, a text file, and it's open all the time, or unless you reboot the system. So these files, these cache files are something that Linux works in that way. It's not a big deal. Sometimes you can say, well, I'm gonna create like my swap disk for RAM. And sometimes let Linux manage that. It does a great way of doing the cache, but the best way you can be sure about that we don't have a memory issue is if you sum or try to sum the cache files in this column and the free space, and if that gives you a number that doesn't make you feel uncomfortable with, that it's going to be part of the chunk of your total memory, it's fine. And the issue with the swap memory is that sometimes, as I was mentioning you, the system tends to open a lot of files and let them cache. And the issue with that is, imagine that comes another process and takes more memory, another process takes more memory, and suddenly the swap system starts saying, okay, we don't have enough memory because we have everything cached. So we are going to be swapping the memory between the disk and the memory. And we are going to be getting in a spiral of downgrading our memory, because the next process that is going to be open is going to be storing the information in disk. And reading from disk is slower than reading from memory. So we're going to be in this game of trying to save in the disk, reading from the disk, loading into the memory, and suddenly we're going to have two issues: memory load and IO load with the disk. So try to see if these cache files can be pushed from some way or something like that. If we start seeing like, and we're going to be checking the IO load, how can we ensure that it's an IO load? But this can happen from systems that hasn't been rebooted from a long time, servers that been for years up and running. So maybe we can find a different way. But if this part of the cache and the free makes sense to a percent of the memory that's going to be free or it's going to be used, it's okay. You don't need to worry about. Also, we have like as a CPU, we have the percent of memory used by different processes like MySQL again, PHP and Memcache and Apache. So not a big deal that I see because the cache, it's bigger than the free, and we're still seeing like numbers really similar to the total amount. So it's not a memory load. And let's say that we start seeing like a little bit of concern with the memory, and we need to see if this is an IO load issue. So the next command I like to run is IO top and IO stat. With IO top, we can see how many transactions per second we have in different disks, and the bulk reads and the bulk writes on each disk. So we start seeing like a lot of reads in the first device. So it's kind of concern. And remember, sometimes systems tend to have different applications. That says we are performing a backup for that server. The system start doing a backup, and a backup can read the whole disk, and it can create a whole. It's not really damage, but remember that reading from the disk is an intensive process. So it can be a degradation of our system because this process is trying to read a lot of information from the disk and trying to pull the data out from the server and trying to perform this backup. Or maybe it's an intense process that we released this morning that is going to be reading from different files. Maybe it's getting all the images of all the users, compressing this file and try to store in an S3 bucket. I don't know. Maybe we are doing a process that is reading a lot of information from the disk, and between the spiral of loading everything to the memory and trying to read from the disk is going to create a memory and IO load issue. On the other hand, IO stat can give us hints about who is executing which command and the operations that are being processed in that particular moment. And we see like here the rsync is getting a lot of disk read transactions and the number of kilobytes per second of those transactions that we are reading. So maybe this can give you a hint of which processes are reading or writing in our system, and we can do something, maybe stop the rsync command because we don't want that in that particular moment or anything else. So let's talk about isolation and stabilize our system. Once we identify what is the load or the high load that we're experiencing from CPU, memory, or IO, we need to track our unhealthy instance because we take a quick peep about what is going on in the servers, what is going on in our instances, and now we can isolate it to prevent future harm, right? While the instance is running, and maybe we can allow that for future investigation. Sometimes engineers ask me if it's okay just restarting. And I could say yes and no, because particularly if we restart an instance that it has data that is being processing for a long period of time or something like that, and we just shut down the instance, we're going to lose data. So the ideal approach is going to be isolate that instance. Identify if the instance is part of an autoscaling group or attached to a load balancer before performing the quarantine. So we can see in our diagram that this is an autoscaling group. So the idea for an autoscaling group is first detach the instance to prevent being terminated by the autoscaling group service due to failing health checks. If we start seeing like, maybe this is part of a degradation, but if we start seeing 100 error in our request, maybe the autoscaling group is going to terminate that instance and we're going to maybe lose data. Or the most important about the isolation is perform forensic analysis about what is going on with that distance, maybe a root cause analysis of what triggered this high load at the beginning. And for elastic load balancer, let's say we don't have an autoscaling group, you will need to deregister it to prevent the load balancer for attempting sending further requests. If we start seeing degradation, maybe we can deregister and this service one that it has a degradation and spin up a new instance, a fresh new instance, and avoid to have all the requests. And maybe we can win time in that part. And once we understand what is happening, maybe we can integrate the instance or terminate it as this is, but we cannot terminate just for terminate an instance without knowing what happened. Once the instance is isolated, as I was mentioned, the autoscaling group will handle the demand of the application and spin up the necessary instances. And once our investigation is done, I suggest that we can shut it down and destroy the instance. Documentation about this. The first thing we should do is to take notes of every event and the people involved. It's necessary that we need to, if something of this is happening, obviously you need to first isolate and set a stable mode of our application. From then in the couple of minutes, once the incident is stabilized, we need to make this summary of what happened, what really happened with the application and the people that were checking this application. Try to set a timeline. This is really a great idea of setting a timeline, and you can construct this timeline with the help of the logs and recreate the incident, but always based on facts, because presenting only facts will help avoid blame other people or other teams and support a deeper analysis. Once you start like doing facts about what happened, you remove the bias of, well, the development team released a new version. It's not our issue. No, we're a team. We're trying to be really objective about what we did wrong. Maybe it's something else. Maybe the code itself was right, but something, maybe a dependency was failing. Maybe the installation or the packaging of the application was failing. I don't know. It will be different factors that we need to really understand before blame someone. We need to be really percent about the facts we are trying to get down. Timelines include important changes and status impact applications and the key actions taken by the responders. Let's say that I create this timeline and first of all, I start seeing like the application was degraded because it was trigger 500s, and I start seeing like all the requests start taking a lot of time. Then suddenly I go to the instance, I SSH the instance, and I run the uptime command and then the top command, and I get the idea that it was like an external command, the rsync command, that start taking a lot of the processes for reading the disk, and then I shut down that command and everything start work up and running as normal. That could be like the summary, but you need to be facing like this timeline with timestamps, particularly when that events happen, how you react, if you ask for help, who respond to that call. To avoid hindsight bias, start your timeline at a point before the incident. Maybe you can go back 15 minutes or 30 minutes before the incident happened and start seeing that maybe the logs in our repository, maybe a new release happened, maybe it was a degradation of AWS, I don't know, but you need to go before the incident. And that way, before the incident, you can start writing forward your timeline instead of backwards. We need to measure impact objectively by answering the following questions. How long was the impact visible? And this is important. If you only notice the impact, but no one else, it's okay. But try to make sure that who saw also this impact. Mostly of the time is the CEO and the CTO. I don't know why, but most of the time at the heads of the organization rather than the users. So how many times were the users customer affected? And how many times, let's say, maybe operations, maybe a model that starts failing for user as customer, how many times did you receive maybe 500s or degradation of the systems? how many customers were affected. And this is really important because we're dealing with people and people's data. So we need to make a summary of, hey, maybe 100 customers were affected because they were trying to upload their profiles or doing a payment or trying to make a purchase in our system. How many customers wrote or called for support about the incident? And we need to contact other areas like support, and maybe in that way we can see how good are our efforts for communicating our customers that we can support them. And maybe we don't have enough channels, like users can call. Who called? No one, but everyone is really angry. And maybe we can give hints to the customer side, the pre-sales or the marketing, like engage a better communication when things can go wrong. And what functionally was affected and how severely. This is also trying to understand the models were involved in this, the part of the infrastructure that was involved in this incident, and how severely. If we deleted 100 records because something bad happened, well, it's bad. And we need to take the severity and the complexity of this incident. Even though we did an analysis at the beginning, and it was a really fast analysis because time is money in that particular situations, we need to go deep and find contributing factors that led this accident. I will suggest I look further back in time to find contributor factors that led to that incident. Contributor factors can be, as I was mentioning, maybe a dependency was bad, maybe something happened when we were packaging the tool, maybe the particular instant that we were trying to spin up was really bad because we didn't update the image for that instance. Whatever, try to figure out contributor factors that affect the issue rather than thinking the most obviously that maybe is the code. Sometimes it's not the code. There is no single root cause in a complex system, obviously. The example of the infrastructure we had is just a really easy system, but we're going to be facing applications that have complex integrations, and maybe some parts were failing. Maybe an integration test failed for some reason, or we weren't covering that integration at all. But a combination of contributing factors together lead to the failure also. Constantly monitor affected systems. Once we start seeing that something is not functioning well, try to set these monitors to these systems or services in order to just make sure that we have a period of time where we're not gonna be worrying about this at all. And then you can set remove that mark of that service because it's getting back to normal maybe in the weekend or a week or a month, whatever makes sense to you and the business. Search for irregularities like sudden spikes or flattening when the incident began. And that's why we use a lot of dashboards. If we see spikes that are not a normal behavior or flattening, let's say, hey, we are not receiving any connections to the database. So maybe that's a particular issue. And we need to be really sure about those spikes and flattening and what does that mean in our dashboards. At the end of a major incident, we need to define an owner. It can be the person that took over ownership of isolate and stabilize the system, or it can be someone else. The idea is that the owner takes the postmortem that will lead to a documentation efforts that we were discussing in the previous slides. And a postmortem is just a meeting where we communicate the findings of our incident to the teams, aligned to facts, always to facts, events, changes. Maybe we changed from instance, maybe we create a vertical increase of the instances, maybe we change some factors in our auto-scaling group policies. Whatever change you did, try to document it there. The status of the services before, in the moment and after, and the impact that we're discussing about the impact of those incidents, and what are maybe the topics that you will be interested about to communicate. Because remember, the incidents we don't want incidents, but we need to communicate them in order like to make better, plan for the future, and don't let like, hey, if I don't tell anyone, maybe no one will notice that we were down like 15 minutes. It's not ideal. We need to take like the responsibility to communicate everyone in the team in order like be aware that that could be a possibility and a risk factor in order like to make better our business and our clients' business. The owner of the Postmortem is responsible for the following: scheduling the meeting and invite relevant people. And please invite just relevant people, not, you know, sometimes meetings can take out of control and we start inviting everyone, but we try to focus in relevant people that can help us to solve possible risk issues with this that we found in the event of the incident. Also, pulling whoever is needed from other teams to assist the investigation is really relevant. Maybe we were checking with the software engineer team or the production team, or maybe we need to call someone from our cloud provider, from AWS or GCP. Whoever can help us to this investigation, please trying to pull this person in the conversation. Creating follow-up tickets and adding necessary documentation, adding to the backlog, or maybe prioritize that in the next sprint, but we need to create the tickets for following up. And reviewing post-mortem content with unprepared parties. Sometimes maybe we don't need to involve the CEO, but maybe we need to involve other areas like marketing, or maybe pre-sales, or maybe someone that needs to be aware that this is a risk. So the postmortem is to invite everyone that could take action after we see this event and we stabilize, and maybe do the better communication about all the users that were affected. How are we gonna be compensating? How are we gonna be communicating that we are working for this and it's not gonna be an issue, because we want happy customers and happy users. And also at the end, communicate the results of the postmortem internally. We need to do like following like the action items triggered by this postmortem. In summary, let's see like the lessons learned. Okay. Overall, when an incident happens, we need to pay attention to events and document facts. Always facts. Look for information in dashboards or data in logs. Also track down the services of instances that could be compromised by this incident, and then analyze services or instances looking for high load that could be CPU, memory, or IO load usage. Most of these issues are related to high load, mostly high load and maybe integration, but in my experience, high load is always there, and we need to do something about that. So the next steps is a good idea to define an improvement plan for the high load, like integrate monitoring agents to your application for CPU, memory, and metrics. If you don't have it, try to integrate those agents. Understand your application's logic. Sometimes as SRE or cloud infrastructure engineers, we don't bother about the application, but that's a bad sign of leading of failure in the future. We need to understand what are we building and the infrastructure supporting that applications, and identify user scenarios. I always ask to the engineers to define user scenarios, happy paths, and edge cases. With those scenarios, we can build test environments where we can stress enough our application and simulate load based on those scenarios. Maybe we start saying like, if we have like an application that is an e-commerce, and we start seeing like in the checkout, the system starts getting slow. With these user scenarios, we can try track down what is happening in the servers, what is happening with all the integration of the services and our APIs, and maybe in the front end, back end, whatever. But try to create these scenarios and perform high load over there. Identify thresholds is measure the limits of the instances you're using. If your applications break faster with high load, vertical growth might be needed. But the issue, well, the thing that we focus on is identify those thresholds based on your load test when CPU and memory starts to collapse. And this is why we define our user scenarios, our happy paths, and edge cases to try to break the application and define when we need to start setting those thresholds. Maybe our application is breaking in the 50% of the CPU because the memory start getting crazy. We need to set thresholds, but also we need to talk with the software engineering team, like, hey, we start seeing a lot of high load with memory. Maybe we can create a microservice for that particular process or model. And it's important to identify those thresholds when you perceive this degradation of your application. Apply a safety margin. Let's say that we start seeing like the 60% of CPU is breaking our application. So maybe we can set up safety margin of 50% to 20%, depends of how wild you like to be in production. So let's say that is breaking in 60, maybe we can go with 45 or 50. That depends on you, and maybe do some tests, maybe do a lot of load tests, and maybe in staging you can perform this test with the stakeholders and some test users plus your high load user agents. And with that threshold, once you define, apply to your auto-scaling groups and not just go with the default of 70 or 80%. Add alarms in your dashboard based on those thresholds and set on call groups. It's really important to have call groups. I think that's it from my part, from the tricks and tips for maybe failing our systems and try to set the thresholds, try to identify the documentation and an action plan. Anyone have a particular question or comment?
We had a question in the chat that I'll flag for you from Miguel. They asked, can the owner of a postmortem be the developers team?
Sure. I think that developers team can be the owner of the postmortem. And the idea of the postmortem is that you can talk with anyone in the team, SREs, production engineers, whomever. You try to figure out to pull all the pieces of the jigsaw and try to understand the reality of what happened in the incident.
Awesome. Thank you, Edwin. Does anyone else have any questions? You're more than welcome to just unmute and share. Or any comments? We've got a hand raised from Fernando.
Hello, Edwin. Does something like chaos engineering can help with to I don't know, to create like these edge scenarios where something fails and can help us to prevent some issues in the production system?
Chaos engineering can help, but we need to remember that the objective of chaos engineering is if we start unplugging everything from our system, how much time we're going to be getting in an normal state of our application, or how our application is resilient to those changes. Yeah, you can apply chaos engineering and start seeing like maybe the thresholds start like making nonsense if something like an attack will happen, maybe a degradation of other systems that are integrating in our main system. So yeah, I could say that we can integrate both approaches, but once we set our thresholds for our application, that we can go with that methodology of chaos engineering.
Okay, thank you. So the first thing will be to define the threshold and then apply chaos engineering, right?
Yeah.
All right, thank you.
Thank you. And we got another question in the chat from Alex. Wouldn't it be a good idea to create two thresholds, one for warning and another one for critical events with different percentages?
Yeah, I think that's a safe place where you can set a threshold for maybe ask for help from an engineer that, hey, we start seeing like this part of maybe it's a warning. we have like both sides of maybe the engineers that are on call in that time, maybe it's not gonna work to maybe warn those engineers, because maybe that happens in the middle of the night and you'll say, okay, let me check. Oh, it was a warning. But I could say that warnings are a good idea if we have like an automated way of taking considerations in that incident. Let's say that we have a process that start working in the middle of the night and try to fetch data from a database, and that we're processing that in the server. And we start seeing like the amount of CPU or memory, it's start increasing, and we surpassing the warning. And our clients from the other side of the world are gonna be like going in this application. So maybe this warning threshold can help us to trigger another event that will like maybe, hey, stop the process, just say what you have, clean the data, and maybe we can resume this process of making the report later, because we are gonna be attending the peak from the users from other side of the world that are in different time zones. But it's a good idea to have two thresholds. But the main threshold that we have, that we want like critical events, is once an engineer will step in and try to solve the issue as fast as they can.
Awesome. Thank you, Edwin. Okay, we have some more questions in the chat. Johan, I don't know if I pronounced that name right. Bear with me. When is there another meeting? Great question. Edwin is in high demand, but we're going to try and have a bunch of events this year for SREs, so please stay tuned. Luis asks, what we do is, I don't know if this is a question, I'm actually just reading this for the first time. What we do is set times for alarms to be resolved. If it hasn't been resolved in X minutes, notify of escalate additional people. Interesting. I think that's a suggestion. Does anyone have any questions? Any more questions? Do you think that it is necessary an on-call scheduling? First, let's answer Martin's question about on-call scheduling, and then Carlos, after that, we can share your comment.
I think it's necessary to have an on-call scheduling. Yeah, it's always important. The idea of the on-call scheduling is that have engineers rotated every certain amount of time. You know, like if those thresholds for a critical event start triggering, they first of all send messages and call to your phone, and automated way of to tell the engineers, hey, something is happening, please go to your computer and check it out. I think it's a good practice to have an on-call, but we need to set our thresholds really well, because we don't want a false positive or a false negative. In order like waking up an engineer in the middle of the night because it was a false threshold. So it's important, and it's our duty to set our thresholds as real as possible to our production state and the things that we can get with all the scenarios that we have defined. Yeah, call is a necessary evil. But again, try to think about those thresholds and not create this bias of, hey, maybe 50% is right. No, maybe that's not accurate for the reality of your application.
Awesome. Thank you, Edwin.